Hi, myself Manoj. I would like to speak about autonomous FinOps for cloud native financial services, engineering cost governance at scale. So, myself, I'm Manoj from Reddy Kalakoti. So, I currently work at a leading global technology company where I specialize in customer electronics and cloud based services, where I lead initiatives in site reliability engineering and platform automations and cloud cost optimizations. With experience in building, scaling, and automating cloud native infrastructure, my expertise with Kubernetes and CI/CD cloud cost governance and infrastructure as code. So, with a strong focus on reliability, performance, and compliance in high regular industries, such as financial services, where I specialized in designing resilient, audit ready platforms and implementing autonomous monitoring for cloud related activities and remedies for the workflow. I'm presenting this automation finance for cloud native financial services. Why I'm presenting this? So the presentation is about this. Financial services are at crossroads, so they are under immense pressure to modernize with cloud native technologies while facing rising costs, unpredictability scaling, and strict regulatory demands. So traditional finance ops models are like largely retrospective and manual, so are no longer sufficient to keep up with the speed and complexity of the Kubernetes-based multi-tenant environments. So as a lead engineer, so I am working as a DevOps. So I see an urgent need for embedding a financial intelligence directly into the engineering cycle. This session is about showing how autonomous FinOps with automation and AI-driven anomaly detection and policy enforcement and audit-ready design can deliver a scalable cost governance without slowing the innovations. Today's agenda is going to be on the finance service cloud dilemma. So, traditional financial operations limitations, platform engineering with finance ops, and autonomous capabilities, and implementing the blueprints. As a financial institute modernization on cloud architectures, right? So the cost governance become both on regularity requirements as a business imperative. So traditional and manual financial operation practices cannot keep up pace with a dynamic and multi-tenant Kubernetes environments, unpredictable scaling, and raising cloud provider costs. And autonomous finance introduce intelligent automations, right? So AI-driven anomaly detection and embedded policy enforced to deliver real-time visibility and continuous optimization and audit-ready compliance by integrating the financial control directly to the development pipelines and operational workflow. So the financial service and organization can achieve scalable cost governance, predictability, and cost spent on strong regulatory alignments without slowing the innovation. So let's go to the next slide. So this slide is about the financial service cloud dilemma, and expand overview on this is so the financial service cloud dilemma, like financial institutions are accelerating cloud adoption to modernize services and stay competitive, but face major hurdles. Legacy systems make migration complex while regulatory demands strict transparency and cost attributes. Multi-tenant Kubernetes environments are scalable but complicate the cost monitoring, right? So especially with unpredictable scaling driven by the market violations and raising cost, provider cost, and a skill gap between the traditional IT finance and cloud native operations further intensify the challenge. And unchecked, these pressurists financial stability and compliance. To succeed, institutes must combine real-time visibility, automated optimization, and strong collaboration between IT finance and compliance teams to balance the innovation and the cost governance. So this slide is about the acceleration digital transformations while managing complex legacy systems and budget constraints, significant skill gaps, complex and multi-tenant Kubernetes environments supporting thousands of workloads. So coming to the next slide, traditional FinOps is falling behind. I'm going to discuss about the reactive analysis, disconnected systems, and slow feedback loops. Traditional FinOps financial operation practices are no longer sufficient for today's cloud-native, fast-moving financial environments, right? So they rely heavily on reactive, retrospective, and cost analysis. So, like reviewing the cloud bills after the fact rather than providing real time insights, disconnected financial and engineering systems create operational slowness, so making it a difficult to align speeding with actual workload. As a result, like feedback loops are slow, often taking weeks to detect the address cost anomalies. So in highly regulated financial systems, so they delay in more than budgeting problems. It continues governance failures, exposing institutions to both financial risks and compliance issues. So the violation of cloud developments has outpaced traditional financial operations, leaving vulnerabilities to cost overrun and regulatory scrutinies. So by the time the cost spike is detected in traditional financial operations, the financial damage is already ineffective. So in the high regulated financial sectors, this isn't the merely a budget concern. It represents a significant a governance failures. So coming to the next slides, we'd like to discuss about the platform engineering and the financial evaluations from reactive monitoring to proactive monitoring, right? So reactive monitoring has post-factor cost analysis, manual works, limited developer visibility, slow feedback on cost anomalies. Coming to the proactive governance from reactive, we have integrated cost optimizations for software development lifecycle, real-time automated insights, empower development, manage speed, and automated anomaly remediation. So, platform engineering elevates financial operations from reactive to proactive, focusing functions to the governance models, like proactive governance models. So, this embed across the entire engineering life cycle instead of relying on cost monitoring and slow workflows. Financial intelligence is integrated directly in developing pipelines given in real time, automated insights, and cost impacts. This approach empowers developers to manage and optimize spend as they build, while automated system remediates anomalies before they escalate. So the results is a balanced model where financial institute gains a ability of cost adoption without sacrificing the cost control, compliance, and financial stabilities. So unlocking a greater efficiency and predictability and long-term value creation for the evaluation process. So coming to the embedded financial intelligence. So here we're going to discuss about infrastructure as a code templates and continuous integration, continuous deployment, financial gates, Kubernetes administration controls, and real-time telemetry. Embedded financial intelligence means building cost awareness and governance directly into the engineering workflow, and rather than treating it as a afterthought, this is achieved through like these four mentioned qualities, like infrastructure as a code templates, CI/CD, Kubernetes administration, real-time telemetry. So by waiving financial control into development and deployment process, financial institutes can achieve continuous cost governance and proactive anomaly detection and predictable cloud spend, like all while maintaining compliance process. So coming to the pre-deployment cost estimations, technical implementations involves leveraging static analysis for infrastructure as a code, Templates for precious resource cost calculations. Utilize historical users' data for accuracy. Integrating directly with a cloud provider, like pricing APIs and real-time stuff. Optimizing costs through reverse instance and saving, like scale down and stuff. Financial governance benefits includes enabling proactive budgeting, validation prior to the development, providing cost estimation with confidence intervals for better financial planning, faculty accurate project level financial forecasting, maintain a clear audit trails for cost approvals. So pre-development cost estimate embeds like financial accountability early in the software development lifecycle by predicting cost spent before workloads are launched. Technically, this involves analyzing infrastructure as a code templates, using historical usage pattern for high traffic or high user data patterns, and pulling the real-time pricing data from cloud providers on the enterprise cloud subnets, or to calculate expected costs, optimizing strategies such as, or as mentioned, reverse instance and savings plans further refine these estimations. For financial governance perspective, these enables institutions to validate budgets proactively, right, and produce a confidence-based forecasting and maintain an audit trail to cost approvals. So this results in more predictable financial planning and reduce the risk to unexpected cloud financial burdens or expenses. Moving on to the slide of policy-based budgeting, gating, define budget policies. So I'm going to discuss about implementing enforce points, build approval workflow, and create a feedback mechanism. So policy-based budget gating enforce financial guardrails throughout the software development pipelines, right? So by defining granular YAML-based budgeting policies to the project, team or application level organizations can ensure spending limits are respected. These policies are enforced at a critical stage of code commits, builds, deployments, scaling events to the previous commits, or reviewing the level of comparison. So to prevent the outruns before they occurs, right? So automated approval workflow handles exceptionals with proper authorization and audit logging. So while real-time dashboards or alerts provide continuous visibility into the compliance and budget consumption. So this approach ensures cloud spending stay on predictability, avoid cost surprises, and maintain regular compliance in the financial services. So coming to the next slide, we have automated tagging and compliance. So automated tagging and compliance of automated finance. So financial operations ensure every resource is accurate, tracked, and allocated and completed. So this includes enforcement, mandatory tag schemas at creation, enabling tagging, inheritance to consistent lineage, and dynamically applying tags based on the deployment context. Tag validation gates with continuous integration deployment pipelines, previously non-compliant deployments, while remediation bots automatically fixes untagged or mistagged resources, right? So comprehensive compliant reports, provider audit readiness, visibility, and accountability, supporting both financial transparency and regulatory requirements. Yeah, coming to the next slide, we are going to discuss on real-time anomaly detection. So this involves time series analysis, resource fingerprinting, and correlation detection, and predictive forecasting. Real-time anomaly detects users' machine learning to move beyond static alerts and provide adaptive and proactive monitoring for cloud spending, right? By applying time series analysis, It identifies devastation from historical usage and seasonal trends. Resource fingerprint creates a behavioral baselines for workloads, while correlations with detection line cost spikes for deployments, and as well as the application events or actionable triggers. So additionally, proactive forecasting projects future costs, right? So with confidence interval, enabling terms to anticipate issues before they escalate, the approach ensures financial institutions can rapidly detect it, or they can investigate, right, and remediate the anomalies by maintaining cost control, compliance, and operational stability, by maintaining the governance in dynamic cloud environments. How like self-healing cost remediation works. So it can help out with anomaly detection, root cause analysis, remediation workflow, and automated actions. So typically self-healing remediation action includes right size over provision resources, automatically applying these compute reservation discounts, suggesting and executing storage tier operations, recommending facility architectural changes for sustaining savings. So, self healing cost remediation represents the next stage of intelligence financial operations. So, where cloud environments not only detect the anomalies but also resolve them automatically to prevent financial leakages and compliance risks. So, the process begins with a machine learning driven anomaly detection, which identifies unusual cost patterns or policy violations in real time. So once flagged, automated root cause analysis pinpoints the exact resource, workloads, or even the deployment change behind the issues. So, based on the severities of the clarifications, a remediation workflow is triggered using predefined playbooks. These workflows may execute in self-service mode or with developer improvements or in a full automated fashion with approvals and complete audit trials to maintain the governance. So these are the common self-healing actions included in the slide. So by combining AI-driven insights, automatic and governance self-healing remediation allows financial institutions to continuously optimize and their cloud environments that they not only reduce costs but also enforce compliance, improves predictability, and enhance operational resilience. Ensuring financial stability is highly dramatic, so they dynamically want to reduce, regulate their cloud ecosystems. So coming to the audit-ready infrastructure design, this includes immutable cost logs, metadata governance, automated reporting. So critical capability providing the financial controls were enforced consistently across all cloud resources at all times. Audit-ready infrastructure in financial operations, so financial services. So in highly regulated financial environments, cloud infrastructure support a comprehensive audit ability and strict financial governance, automation, finance operations, solution address. These need to be provided immutable cost logs, standardization metadata schemas, tamper-proof recording for all financial decisions, approvals, cost attributions. So those systems enable automated reporting aligned with regular frameworks such as GDPX, SOX compliance, PCI compliance, DSS. So ensuring these financial controls are constantly enforcing across all cloud resource at all times. Pre-built reports and structural governance framework simply compliance reduce the risks and provide verifiable evidence for the audits. That helps, yeah. Coming to the next slide, building up the financial platform for technical implementation blueprints. So the core components involves cost estimation, service integration with infrastructure as code, policy engine for budget enforcement, financial telemetry, collection and storage, machine learning, pipeline for anomaly detection, remediation workflow, and orchestration. So integration points involves, but not less than, version control pre-commit hooks, continuous integration, continuous deployment, pipeline stages, Kubernetes administration controls, cloud provider APIs and event streams, existing observability platforms. Building your financial operation platform for a technical blueprint is a robust platform, financial operation platform that combines cost, services, and strategic integrations to manage cloud cost efficiently. And core components includes a cost estimation service integrated with infrastructure as a code, and a policy engine for budget enforcement as mentioned. So not only the financial telemetry collection and storage, but the machine learning part, anomaly detection pipeline. So to maximize impact, organizations should focus on value integration points first and expand to the platform integrations and to ensure scalable and sustainable financial operation systems. Coming to the next slide, so we're going to discuss about measuring financial success for cost reduction, cost predictability, policy compliance, and response time. Measuring the financial success is in financial services, right? So efficiently evaluating the financial success requires a multidimensional approach that goes beyond simple cost savings. One key metric is cost reduction, which measures the quantifiability savings, but achieving through the autonomous optimization and intelligent cloud management. Like also compared to the traditional manual methods, complementing these to a cost predictability which tracks percentage to cost spend that constantly aligns with predefined forecasting ranges. That enables organizations to plan budgeting with a greater accuracy and reduce financial uncertainty. Another critical measure is policy compliance, where to ensure that all cloud resources are currently tagged and allocated to the respective cost centers. This not only maintains ad hoc to the financial governance, but also provides clear visibility to audit and regulatory reporting. Beyond these direct financial metrics, a successful financial operations program, I would say, also delivers broader organization value, right? Improve financial governance, reduce the risks to audit discrepancies, and regular penalties. So enhanced self-service capabilities empowers developers and the cloud team to operate more efficiently forecasting, involving while maintaining cost discipline by combining measurable savings and predictable budgeting and regulatory compliance, also a rapid anomaly response. Organizing these can historically assess the impact of their financial operations initiative and ensure the cloud investments deliver both finance and the benefits of the organizations. Coming to the final slide on the takeaways. So the key takeaways are shifting finance operation lift, empower engineering, automate governance, design for the compliance. Coming to the key takeaways for efficient financial operations implementation. So this is important because to achieve maximum impact for financial operation initiative, organizations must adapt a strategic, proactive that embeds financial intelligence throughout the software delivery lifecycle, and shifting financial operations left ensures the cost valuable and financial controls are integrated earlier than the expected. So in this development and deployment process. So allowing teams to anticipate and migrate cloud spending risks before they escalate, right? Also, equally important in empowering engineering teams while self-service tools and actionable insights are in action. While developers and excuse and operations have ability to make information cost conscious decisions without bottlenecks and other issues. So organization benefits from fast innovation cycle, improved accountability and risk reduce for budget overruns. Automating governance in other critical is the other critical pillar for the financial operations initiative. By moving from manual reviews to automated policy enforcement, so financial controls can be considerably applied across all cloud resources at scale, reducing human errors and ensuring compliance with internal policies and external regulations. So finally, designing for compliance is essential in regulated industries. So systems must be architect for audit readiness with immutable logs, transparent financial records, and standardized report framework that demonstrates ad hoc to regular regulatory requirements. So by combining proactive cost management, developer empowers automated governance and compliance focused designs. Organizations can optimize cost investments while maintaining financial discipline, operational effectiveness, and regulatory assurance. So this is about the financial operations initiative, and thank you.